All right, here I want to talk about modulus or the remainder operator and integer division. So these are two operators which I've already mentioned, but we're going to be using these, particularly the modulus or remainder operator, quite a bit. So it's worthwhile spending a little bit more time on. First of all, let's say you had a problem of converting seconds to minutes and seconds. So for example, let's say you had this many seconds. That's a lot of seconds. So we'd like to be able to convert that to a whole number of minutes and the leftover number of seconds. And so we can do that very easily with these two operators. So we're going to have a certain number of whole minutes. I'm assuming everything is integers now, and I'm not worrying about hours at all. My whole minutes are going to be the number of seconds that I started with, integer divided by 60. All right, now Zelli talks about this in chapter 2 or 3. It might be one or the other, so I'm not entirely sure. But basically, this is the whole number of times that 60 will go into 1, 2, 3, 4. So that would be the whole number of minutes. And then the leftover number of seconds. So I'm coming up with these named variables to hold the result of these calculations. Is the initial number of seconds percent 60. Okay, so this now is the modulus operator. This is integer division rate, these two divide symbols together, which are different from just divide, because that would be normal division. And this now tells you what the leftover amount, integer amount, is if you divide 1, 2, 3, 4 by 60. And so whole minutes, just going to highlight this, bring it down here, type it up. So that would mean we had 20 whole minutes in 1, 2, 3, 4 seconds, and leftover seconds is 34. All right, so that must mean that 20 times 60 plus 34 is 1, 2, 3, 4. This kind of shows you how these two things can work together. Now we're going to be using integer division somewhat, but we're going to be using the this modulus or remainder operator quite a bit. And one of the reasons is that we can use it to test to see if numbers are divisible by a certain integer or not. So for example, to show you how that works, let's say I had the numbers 21 and 22. So let's see, 20 and 21. Let's go 20 and 21. So 20% 2 has a remainder of 0. 21% 2 has a remainder of 1. And so if you think about it, if you take an integer and you divide by 2, there's two possible outcomes. You're either going to have a remainder of 0 or you're going to have a remainder of 1. Those are the only two possibilities. You're not going to ever have a remainder of greater than 1. If the remainder is 0 and you do a %2 here, that means the number is divisible by 2. Otherwise, it's not. And so I can now set a Boolean up, and I can go, for example, I can go for num in range 2, 10. Print num, num %2. All right, now what's this going to do? First of all, it's a for loop, and I've got a range statement, so it's going to num is going to vary from 2 to 9. 2, 3, 4, 5, 6, 7, 8, 9. Then inside the for loop, I have a print statement. It's printing out two things. It's printing out the number as it traverses this implicit list, and then it's going to print out num %2. In other words, it'll print out the remainder when num is divided by 2. So let's just go ahead and run this. You can see that if you divide 2 by 2, you get a remainder of 0. If you divide 3 by 2, you get a remainder of 1, etc. Okay, so now let's change this a little bit. Let me do an Alt-P here, and let me do this instead. I'm just going to change this a little bit. All right, so what I'm now going to print out, I can move this up so you guys can see it, is I'm going to print out whether or not the remainder is 0 when you divide by 2. Okay. All right, so the remainder is 0 for 2, 4, 6, and 8. The remainder is not 0. It's in fact 1. If the number is 3, 5, 7, or 9. Okay, so let me change this once more just to show you a little bit more about booleans. And so instead of doing this, let me do not equal to. And the way you do this in Python is you go exclamation point equals 0. And so that would mean that the remainder when you divide num by 2 is not equal to 0. So I'm switching the logic here. So if I do that, now if num is %2 is 0, that's going to be false, and so I've toggled the output here. So what was previously true is now false. So for example, for num equal to 2, num %2 is 0, and 0 is not equal to 0 is a false statement. And for num equal to 3, 3%2 is 1. That would be the second time through the loop. And 1 not equal to 0 would be a true statement. Okay, so we're going to be using this modulus % operator for various things, and it also shows how you can test for divisibility by 2. I've shown you divisibility by 2. You could use num %3 to test for divisibility by 3, etc.